This video is a continuation of the Introduction to Acids and Bases notes. In this video we're going to discuss naming acids and bases. So naming acids, recall most acids start with a hydrogen. So examples are HCl, HBr, H3PO4. The name of the acid focuses on that anion, that negative ion in the formula. Or that non-hydrogen element, or it could be a polyatomic ion. So some examples of the names of these ones that were listed: HCl is hydrochloric acid, coming from chlorine. HBr is hydrobromic acid, coming from that Br, bromine, anion. And then that phosphoric acid is H3PO4, coming from that phosphate polyatomic. And as a reminder, here are the polyatomics that we use most often in this class, so these are the ones we need to know. The only one of these we wouldn't see in an acid is ammonium, because hydrogen is a positive 1 charge, so it wouldn't go with that positive ammonium polyatomic. So as we look at these examples, what are some things that we start to notice? Well, we've got some names that have hydro in the front, but we have one that doesn't. So as we're kind of looking at patterns here, one thing to note is that in that HCl, we have just chlorine, and in that we have hydro as a prefix. For bromine, that HBr, we have hydro as a prefix, but when we have this polyatomic PO4, we don't see that prefix of hydro, it just goes right into the root of that polyatomic. And so because we might see like a hydrochloric acid or a chloric acid, those two mean different things. We have different naming conventions if we're using something like chlorine or if we're using a polyatomic like chlorate. So when we are naming acids, we can kind of think through this flow chart. We can notice an acid because its compound starts with an H, or it might say acid in the name. When we have an acid that is just 2 elements, so it would be hydrogen and some other negative ion, we are, when we're naming, add that hydro prefix to the anion element, and then we're going to change the original ending of that non-hydrogen element to "ic," and then we add acid on the name. And so an example would be if we're looking at an acid, H3N, hydrogen and nitrogen forming an acid, because it starts with an H in the compound. We have 2 elements, hydrogen and nitrogen. Then we take that nitrogen, we add a prefix of hydrogen or hydro. So hydro, we take the root of that and change the ending, so nitric, and then acid on the end. So anytime we have just 2 elements, hydrogen and one other nonmetal, forming that acid, then we are going to follow this naming process. If we have a polyatomic, then we're going to have some hydrogen ion that is forming a compound with a polyatomic. Polyatomic means that we're going to have 2+ elements that are forming that ion. Usually we only have 2 elements forming that ion, but so we can recognize it by 3 elements, but really this is just 3 or more. So a hydrogen and then multiple elements in that polyatomic. And because we have polyatomics like nitrite and nitrate, we need to be able to distinguish between those 2. And so if we have an acid, our compound starts with an H and it's 3 elements, meaning it has a polyatomic in it, we need to consider what the original ending of the polyatomic was. So if that polyatomic had an 8 ending, like nitrate, NO3, so if we look HNO3, it starts with an H in the compound. I have 3 elements, hydrogen, nitrogen, oxygen. That NO3 is nitrate. I am going to change the original 8 ending to ic or to auric. I'm not going to get mad about spelling on that. Really, it's just does this, which one sounds the best. And then So notice we have that nitrate changing the ending to ic, so nitric, and then saying acid. And that's what can differentiate from hydronitric acid and nitric acid, is that without that hydro, we know we're using that nitrate polyatomic. If that was an ite ending, so we have HNO2, NO2 is nitrite, we change the original ending from ite to OUS or to OROUS, and then add acid on the end. So that nitrite, getting rid of that ite ending, so nitrous acid is the compound, the acid made with nitrite. All right, if you want, go ahead and give some of these a try on your own. Otherwise, try them with me. Looking at these and naming the acids, I've got HBr, those are 2 elements. So I'm going to look at what is my negative ion. So I have bromine. I'm going to add the hydro prefix. So I've got hydro, and then I get rid of the original ending and change it to ic. So I'm going to get rid of that ine, adding that IC ending, and then I say acid. So I've got hydrobromic acid is HBr. On to the next one, H2CO3, well, starts with an H in the compound. I have 3 elements, so I need to look at, well, what is this polyatomic? And looking at my CO3, that CO3 is carbonate. So I take that, I've got 3 elements, carbonate, ATE ending. I'm going to change that original ate ending to an ic or to oric. So getting rid of that ATE, I'm going to have carbonic, and then I also add on acid. So carbonic acid for H2CO3. H2SO3, looking at that SO3, because I have 3 elements, hydrogen, sulfur, oxygen. Now I need to consider what is the ending of that polyatomic. And we've got sulfite. So I've got 3 elements with that ite ending, changing the original ending from ite to OUS or to OROUS. This is one where, because sulfur normally ends in an R, using that OR, so sulfurous acid. This is one where you would use that OROUS, and really it's because sulfur ends in an R, and so that sounds a little bit better. If you said sulfurous acid, I would count that. Feel free to pause, try these next ones on your own, or do them with me. HI, I've got hydrogen, starting with hydrogen, but I just have 2 elements. So I'm going to look at my second element, which is iodine. I'm going to, because it's just 2 elements, not a polyatomic, I'm going to add hydro as a prefix. So I've got hydro, and then I've got to change the original ending to ic, so taking off that ine. So I'm going to have hydroiodic, and then acid on the end. HNO3, this starts with an H, so it's an acid. I have 3 elements, so I need to look at that polyatomic. What is the original ending? So I've got NO3, which is nitrate. So looking at an ate ending, changing that ending to ic or to oric. There's already that R in that nitrate, so we just go nitric, changing that to IC ending, and then acid. So nitric acid. And then this last one, H3PO4, I see that I have, starting with an H, 3 elements because I can see that polyatomic of PO4, which is phosphate. So that phosphate ending, changing that 8 to an ic or to an OR, IC. And this one, so phosphoric acid or phosphoric acid is actually the preferred, is phosphorus. If we get rid of that R, from that, having that auric. Sounds a little bit better. I would accept either of these. All right, now let's try to write the formula if we are given the name. So hydrofluoric acid, we're kind of going opposite, trying to figure out what are some of the distinguishing characteristics. I see this hydro, which means that I'm going to have just two elements. One of those elements, it's going to start with that hydrogen. So because this is an acid, we have that H plus 1. And then looking at the root, what element is this talking about? Looking at our periodic table, fluorine has a -1 charge. And so I'm going to drop and swap +1, -1. And so this is HF is the formula for hydrofluoric acid. Sulfuric acid, I don't see that hydro, meaning I need to look at what polyatomic would this be. So no hydro means we're looking for a polyatomic, but that IC ending is what I have if my polyatomic ends in ATE. So I want to consider what is the polyatomic of sulfate. It's an acid, so I have hydrogen with a +1, and that is going to form a compound with sulfate, which is SO4 - 2. Then to make that a neutral ionic compound, I can drop and swap. So we'll have H2SO4. All right, nitrous acid. Again, I don't see there's not hydro on the name. So that means I'm looking at, which of my nitrogen polyatomics is it? Is it nitrate or is it nitrite? But that OUS ending is what I use if my polyatomic ended with an ite. And so this is going to be a acid formed with hydrogen and nitrite. So we've got hydrogen, which is +1. Nitrite is NO2 with a -1 charge. So we drop and swap, and we get HNO2. Take a minute to try the next couple on your own, and then come back to see the answers. Pause the video if you need. All right, hydrosulfuric acid. That hydro shows us that we are going to have just hydrogen and sulfur in that acid. So we have H2S when we make that a neutral ionic compound. Hydrophosphoric acid, again, the hydro means this is a acid with hydrogen and phosphorus. And then sulfurous acid, there is no hydro in the front, so that is with that sulfite ion, H2SO3. All right, last thing we have is naming bases. There's luckily nothing new to learn about naming bases. They are ionic compounds that have that hydroxide polyatomic. So we've been naming bases since the start of the year. We are going to have a positive metal cation that is in a compound with an hydroxide ion, which is OH - 1. If we have a transition metal, we need to make sure we include the charge using Roman numerals in the name. So if we are naming the bases below, SrOH2, well, Sr is strontium, but that is in group 2, so we always know the charge is 2. So this would just be strontium hydroxide. NH4OH. NH4, remember, is our ammonium polyatomic, and so we could see ammonium hydroxide as a base. CuOH3. Well, Cu is copper, but copper is a transition metal, so we need to say what the charge is. So we've got that copper hydroxide. Figuring out the charge, because OH has a -1 charge, however many OHs we have, that's going to tell us what the charge is. So I have a -3 charge from my OHs, meaning copper is going to have a +3 charge. So we would say copper 3 hydroxide using those Roman numerals. Writing the formula for a base, same as when we've been writing ionic compounds in the past. Aluminum hydroxide, aluminum has a +3 charge, hydroxide has a -1 charge. So when we do our drop and swap, we're going to get Al parentheses OH3, just making sure you're using parentheses so we can see we have 3 hydroxides. And this last one, zinc 2 hydroxide. Zinc is a transition metal, so it'd be zinc with a +2. Hydroxide is OH - 1. So when we drop and swap, it would be Zn parentheses OH2 for that zinc hydroxide base. That is the end of these Introduction to Acid and Base notes. There is a worksheet that covers everything we've talked about, the basics of acids and bases, Bronsted-Lowry acids and bases, conjugate acids and bases, and naming. And then there are also check-ins available. Please reach out to your teacher with any questions.